Welcome to part 1 of our comprehensive guide on understanding welding symbols. In the world of metal fabrication, precision and clear communication are extremely important. The ability to accurately read and interpret welding symbols isn't just a skill. It's absolutely critical for welders on the shop floor, supervisors overseeing production, engineers designing structures, estimators bidding a project, and quality personnel ensuring compliance. These symbols are the universal language of welding, communicating vital information about a joint's preparation, the required weld type, size, and even finishing details. If you've ever looked at a blueprint and felt overwhelmed by these precise graphical instructions, you're in the right place. In this video, we're going to equip you with the essential knowledge to confidently read, interpret, and even begin to write them. Let's dive in. Basic components of a welding symbol. Every welding symbol at its core has two basic components, an arrow and a reference line. The arrow points directly to the location of the weld on your drawing. The reference line, on the other hand, is where all the crucial information lives. Details like the type of weld, its size, and other important specifications. You'll notice that the arrow isn't always pointing in the same direction. This is perfectly acceptable. Its orientation varies simply to fit the symbol neatly within the available space on a blueprint or shop drawing. All the variations you see here are correct. Before we go any further, it's vital to clarify a common point of confusion. The terms welding symbol and weld symbol are often used interchangeably, but they are not the same thing. The American Welding Society defines a welding symbol as the complete graphical representation that conveys all the specifications needed to produce a welded joint. Think of it as the entire instruction set. A weld symbol, however, is just the graphic character connected to the reference line that specifically identifies the type of weld or joint geometry, like a fillet weld, or in this example, a bevel groove weld. Understanding this distinction is key to avoiding confusion as we progress. Now let's look at the variety of weld symbols you'll encounter. There are distinct weld symbols for everything from fillet welds to slot welds, plug welds, and numerous variations of groove welds. This chart illustrates the many different weld types represented. In addition to the basic weld symbols, we also have supplementary welding symbols. These symbols provide additional instructions or characteristics about the weld, such as whether it's a field weld and if it goes all around the joint, or if it needs a specific contour such as flat, concave, or convex. While this tutorial does not cover blueprint reading, a quick review of orthographic views is essential, as this is how most prints will call out welds. An orthographic view is a way to represent a three-dimensional object using multiple two-dimensional drawings, each showing a different side of the object. These views are created by projecting the object onto a plane perpendicular to the line of sight, essentially showing what each side looks like without any perspective distortion. In orthographic views, you'll typically see a top view, a side view, and a front view of the part. While pictorial views are less common in shop drawings, the other three are standard. Most drawings will include all three main views. This not only shows you the exact location of the weld, but also helps you determine its length and other dimensions, as component dimensions are also provided. It's also critical to understand the 5 basic joint types you'll encounter in fabrication. These are the butt, corner, T, lap, and edge joints. It's important to recognize these and understand that various weld types can be applied to each. For instance, a T joint might feature simple fillet welds, or be prepared for a more complex double bevel weld. The placement of the weld symbol on the reference line is very important. This dictates which side of the joint the weld must be made. As you can see, if the weld symbol is placed above the reference line, the weld should be made on the opposite side of the joint to which the arrow points. Conversely, if the weld symbol is placed below the reference line, the weld is to be made on the arrow side of the joint. This image further illustrates that point, specifically with a fillet weld. Notice how the arrow stays in the same place, but simply moving the symbol from below the reference line to above the reference line changes which side of the joint will receive the weld. This seemingly small detail has a massive impact on execution. If the weld symbol is placed incorrectly, the welder will place the weld on the wrong side of the joint, and this can be very costly. Now let's zoom in on one of the most common weld symbols you'll encounter, the fillet weld symbol. The fillet weld symbol is represented by a right triangle, and critically, the side perpendicular to the reference line always faces to the left. Just like with the general weld symbols we discussed, this symbol can be placed either below or above the reference line. When the fillet weld symbol sits below the reference line, it indicates that the weld must be made on the arrow side of the joint. Conversely, if the fillet weld symbol is placed above the reference line, it means the weld must be made on the other side of the joint. This is a fundamental concept that you'll use constantly. What if you need a fillet weld on both sides of a joint? Thankfully, the welding symbol system is efficient. For double-sided fillet welds, you'll see the fillet weld symbol placed both above and below the reference line, indicating that a fillet weld is required on both sides of the joint. By using this double-sided fillet weld symbol, we can clearly convey the requirement for welds on both sides of the joint with a single concise welding symbol, rather than needing two separate ones. It's a cleaner, more efficient way to communicate. Now, how do we specify the size of a fillet weld? Fillet weld sizes are indicated by placing the dimension directly to the left of the fillet weld symbol. When you see a single dimension here, it means both legs of the fillet weld are that specified size. If the legs of the fillet weld are unequal in size, both leg dimensions must appear to the left of the fillet weld symbol. There's no specific order for these dimensions. The drawing itself will specify which leg corresponds to which size. Sometimes a note in the tail section of the welding symbol will clarify this, which we'll cover shortly. Sometimes a weld isn't continuous along a joint. For these, we use intermittent fillet welds. Intermittent fillet welds are specified by indicating the length of each weld segment and the pitch. The pitch is the distance from the center of one weld segment to the center of the next adjacent segment. So for example, 2-5 would mean a 2-inch weld segment followed by a gap, with the next segment starting 5 inches from the start of the previous one. Just like with continuous fillet welds, intermittent fillet welds can also be double-sided. If you see another fillet weld symbol on the opposite side of the reference line, it means you'll have these intermittent welds on both sides of the joint. In many fabrication scenarios, especially with double-sided intermittent fillet welds, the weld segments are staggered. This is a technique used to help distribute heat more evenly and minimize distortion in the workpiece. The welding symbol for staggered intermittent fillet welds is very similar to the regular double-sided intermittent symbol, but with one key difference. The symbols will be offset from each other on the reference line. This offset indicates that the segments on one side are not directly opposite the segments on the other. Supplementary welding symbols for fillet welds. Beyond just specifying the weld type and size, supplementary symbols provide even more detail. These apply not just to fillet welds, but to many other weld types as well. The all-around welding symbol is a small circle placed at the junction of the arrow and the reference line. This symbol indicates that the weld must be completed all the way around the joint, regardless of its shape. It's not just for round parts, it can apply to any closed shape where the weld needs to be continuous around the perimeter. The field welding symbol tells you where the weld needs to be made. This symbol, which looks like a small flag, specifies that the weld must be performed in the field, meaning at the construction site, as opposed to in the shop or fabrication facility. The flag can point in any direction and may be placed above or below the reference line. Sometimes you'll see a single reference line with multiple arrows. When the exact same type of weld is required in several different locations on a part, a single reference line with multiple arrows can be used to efficiently convey this information. Each arrow points to a distinct location where that specific weld should be applied. Welding symbols can also specify the desired finished contour of the weld, whether it needs to be flush, slightly concave, or slightly convex. The contour welding symbol is a small line or arc placed directly above or below the weld symbol, taking the shape of the desired finish. If no finishing method is indicated, it's assumed that this contour must be achieved through the welding process itself, or by the finishing method of your choice. However, achieving a perfect contour by welding alone isn't always feasible or practical. In such cases, a specific finishing method can be called out. These methods ensure the weld achieves the specified contour. Common finishing methods include chipping, grinding, hammering, machining, planishing, or rolling. Finally, let's talk about the tail section of the welding symbol, a versatile area for additional information. The tail section can contain supplementary data that helps the welder, inspector, or others involved in the process. This information can range from specifying the exact welding procedure specification, or WPS, to be used, to referencing additional drawings, codes, or quality control specifications. It's a powerful tool for conveying critical details that aren't covered by the main symbols. And there you have it, the foundational components and critical concepts for reading welding symbols. Understanding the arrow, the reference line, the difference between a welding symbol and a weld symbol, and the significance of symbol placement are your first steps to confidently interpreting blueprints. Practice is key, so keep looking for these symbols in real-world drawings. If this video helped you decode welding symbols, please give us a like, share it with fellow welding professionals, and subscribe to our channel for more valuable insights. Thanks for watching, and happy welding.